Hi guys, in this video I'm going to go through this LeetCode problem 54. So we are given an n by n matrix. We need to return all the elements of the matrix in a spiral order. So this example has a good illustration. So we go from the top left, and then when we hit the wall, and then change direction. When we hit the wall again, change direction. When we go up, when we're hitting something we have seen before, and then we change direction. And then we move, and then we ended up at the circle at the center. And this one is very similar, but instead of an n by n matrix, we have an n by m matrix. The number of rows is not the same as number of columns, so this one should work as well. So let's dive into the solution. And first, we need a direction list, and what we need is so the first direction is from 0, 1. So we're basically moving horizontally from the left to the right. And then next one, we're going vertically from the top to the bottom. And that's going to be 1 and 0. And then we move again horizontally, but this time it's from the right to the left. So it's going to be 0, -1. And next one is going to be vertically from the bottom to the up to the top. So it's going to be -1 and 0. And so that's all the possible directions. And we have a direction pointer. I will show you how I use that later. So basically, it's pointing which direction we need for each step. And then we will update this guy whenever we hit the wall or we hit something that we have seen before. And we also need a visited. So it's a set. So we keep track of all the coordinate that we've been seeing. We have previously seen, so we don't duplicate our work. Also, we know when we need to change the direction. For example, 4, when we still move up, that is something that we have seen before. That's why we need to change the direction. And then we need the number of rows. And also number of columns. And also we need a result. And that's pretty much it. So we need a current row and also current column. And we at the beginning at the top left coordinate. So that's why 0, 0. So while the length of the visited set is now equal to, it's less than the number of points. So that means we have not yet seen everything. If this is equal, we have seen all the possible points in the matrix. And while we have not yet seen all the possible points, we keep doing the work, executing what is it in the while loop. So we have a current direction x, and also current direction y, and that is equal to the direction. And we have the direction pointer, take the modulo of 4, because we have total 4 elements in the direction list. So it allows us to go backward in here. After we move this direction pointer, go back to this one. For example, this one 0, 1. So the pointer is 0, the pointer is 1, pointer is 2, pointer is 3. When the pointer is 4, and take the modulo of 4 and then go back to the first one. And the pointer is 5, and then go back to the second one, etc. That's why we need to take a modulo of 4. And we need the first number in the tuple. That's for the x. For the y, we need the second element. So that's our current direction tuple, and also we have the next, and stand for next row and next column. That's equal to the current one plus direction. And if the next row is within the boundary and not hitting any walls, same for the column. Also, yes, the next one is something that we have not yet seen before. In that case, we update the current position to be the next one, so we are safe to collect the value because we are not hitting any walls and we are not in the something that we've been seen before. We are not in the scene set. We're not in the wasted set. So in that case, because we are seeing it right now, we add it to it. Also, we are collecting the number. Otherwise, that means the next row and next column will be something either hitting the wall, or if it is that's in something that we have visited before. If that's the case, we have to change the direction, right? When we hit the wall, we change direction. When we have seen something before, we have to change direction. So how can we do that? This is how where the direction pointer comes into handy. So first we have to move backward, right? Because we are the next one is hitting the wall, so we have to move back, and then we have to update the pointer. This is where we change the direction. Change direction, and after all that, but we are missing one case, which is in the top left point, because we are already moving in here. That's why we are missing out this point. So how can we do that? And it's easy. We just add to it manually as this is only one point. Okay, so also we put in this visited set. Zero. Okay, so at the end, we will return the result. Let's see. Oops. Here to the adding the tuple. Okay, works for the test case. Okay, works. So the time complexity for this code is nr times nc, because we're basically executing here. We're looping for all the possible points. And for the space complexity, we have also n times m, because we have this visited set that keep track of the other coordinate. Also with the result list that is collecting all the possible result. I mean all the possible numbers within the matrix. So this is my solution to this problem, 54 spiral matrix. Though this question was quite popular, as you can see, it was asked by so many companies. I hope you like it, and hopefully I will see you in the next video. Thank you.